Welcome to the session on the working group on HPC AI. So let's get started. We have a kind of a packed schedule. So this is the agenda for today. So the welcome and the introduction to what this working group is. It's a brand new working group, actually. So the very quick introduction to the working group. And then we have a guest speech and a keynote speech by Professor Sumidate and a guest speech by Dr. Damayanti Herath. We'll also introduce launching the APAN Conference to be hosted in Hong Kong with APAN60. And also we'll be introducing the white paper on HPC AI for the Asia Pacific region. Without delay, let's get started. A very quick introduction, actually. I'm not going to take too much time on this one. The working group on HPC AI, we started at the Bird of Feathers at APAN57, actually. APAN called for expression of interest or proposal. We submitted one and it was just accepted. APAN was actually planning to have it starting at APAN58, but we requested APAN, and they advanced the setting up of the BOF or the build for this to APAN57. That was in Bangkok. And we had the second meeting at APAN58 in Islamabad. So after 2 meetings, as per the rules and regulations, we are officially recognized as a working group from this APAN59 onwards. So basically the idea of the working group is to have discussions and the initiatives that related to the advancements and applications of HPC and AI within the APAN network in the region. It includes, but not limited to, research collaborations, teaching, technology sharing, capacity building, and the development of innovative solutions for common challenges. So that's, I will talk about that later when we are looking at the white paper. The scope and the objectives very quickly to basically to connect and inspire each other, to upskill the workforce, bridge the HPC AI divide within the region, empower the regional progress to the HPC AI, as we already all know now how much of progress that are happening around the world, and to ensure that everybody within the region can participate in this and ride that wave to become developed as well, and drive innovation within the region. Okay, so those are the objectives. Just to give you a very quick background about the working group. So without taking too much time, since we have too many important things to address, let's move on to the guest speech. And it's my pleasure to invite Dr. Damayanti Herath. She's a senior lecturer from the University of Peradeniya and APAN59 fellow. She's, even though she's, actually this is the first time I think she's attending an APAN meeting outside Sri Lanka, but she's not a stranger to APAN committee, because with her leadership we started the APAN conference back in 2023 in Sri Lanka. We launched, and she was the one who was driving it from the beginning. And she's been the main conference chair for the last 2 times, and will be chairing this time as well. So this is a photo from her from APAN56 conference. She's no stranger to APAN. So it's given me great pleasure in inviting Dr. Damayanti Herath to address you. Sorry, what happened? So to talk to you about her experience in using GenAI in engineering education, a case study based on what she's doing at the Department of Computer Engineering at University of Peradeniya. So Damayanti, over to you.
Thank you for that introduction. Good morning, everyone. I'm really happy and excited to be standing here. And first of all, I thank APAN for giving me the opportunity to be an APAN fellow and be talking about a little story to you all, sharing a story with you all on generative AI, a case study from engineering education. I'm Damayanti Herath, and I studied at the University of Peradeniya, Sri Lanka, and later completed my PhD at the University of Melbourne, Australia. And now I am back at the University of Peradeniya as a senior lecturer of the Department of Computer Engineering, as well as I'm serving as the Director of Engineering Education Unit. Most importantly, what I wanted to highlight was about the University of Peradeniya. It's the oldest university in Sri Lanka, as well as it's a large residential university and one of the most beautiful universities in the world. So this is the view from my window. So as educators, we also try to use this beautiful environment and try out different things to improve the way how we do teaching and learning at the university. Being in such a beautiful setup encourages, inspires us more to do different things. Like we take the students outside and have sessions with them. We can have discussions in our open air theater, etc., etc. So we try different things as educators. At the same time, there is this study that came in around 1980s. It's called as Bloom's 2 sigma problem. The idea, the concept there is, it shows how the student performance varies across different teaching learning strategies. So in it, and he proposed, he showed that by through an approach like mastery learning, where you do repeated reflection, through mastery learning, you can go 1 sigma ahead than the traditional teaching and learning. But more than that, if we could do one-to-one teaching, tutorial, that is what is referred as tutorial here, you can go 2 sigma, is that correct? Right? We can go 2 sigma ahead. We can see a performance improvement of 2 sigma compared to the traditional classroom-based typical setup like this. So, but how can we enable that, this one-to-one teaching and learning? Turns out, we all know in around December 2022, there was a buzz or a wave that came, the generative AI. So we also wanted to see how we can use this interesting advancement in technology, generative AI, to improve the way we do teaching and learning at the Faculty of Engineering. So this is the story I'm going to share about. Basically, I wanted to share how we integrated generative AI especially into teaching and learning in the engineering undergraduate research component. With respect to related work, so that it has a theoretical foundation, I wanted to share that there are, of course, already done related work across this topic. Different people have done studies looking at how generative AI can be integrated into teaching and learning across different disciplines, especially in engineering discipline as well. So, these are the use cases, or these are the use cases. So how it is applicable to engineering education, like it can be used for personalized learning, content generation, programming assistance, especially in programming assistant, visualization, so we know there are vision-based generative AI tools and of course text-based Gen AI tools, and then it can be used for assessment support in a scenario to provide AI-powered grading and feedback to evaluate student performance. So all what is the motivation for all these is to give a better environment for the student, for the teaching and learning. And here's an example of the study looking at how ChatGPT can be utilized into how a comparison between using ChatGPT with use case looking at the MATLAB coding in a traditional setup versus using ChatGPT. All right, in terms of my story, it goes like this. We have, in this particular student cohort I'm looking at the department, we had a cohort of 60 students. And in their final year, they follow research. They have to follow 2 semesters, basically 30 weeks worth of timing on final year undergraduate research. In the first semester, they would focus on problem formulation, doing a thorough literature review, summarizing of the related work, and then the next semester they will go on to experimental design, results analysis, and and writing up their work. So that's the typical setup. So in this iteration that I'm talking about, what we did was we decided, okay, let's integrate generative AI into this process, and let's us involve the students as well as much as possible in this process. So we started off by defining and actually restructuring our evaluations to match this purpose, and then we did the course delivery, and time to time, at different time points, we measured how we are doing through student feedback and the evaluators' feedback. So we began with having a discussion with the students. It was at that time, in around 2024, early 2024, at that time, it was not that much integrated into teaching or learning. So it was new to the students. So we had a discussion with them to start with, introducing them formally what is generative AI, what it can do, and what are the ethical implications around it, what sort of tools. The session was in fact done by Professor Oshan Ragel, who is in the audience. So we did a session to the students. We introduced this first. And so these are, at that time, these were the tools, example tools that we introduced them. And we told them, you are free to use this if you would like, without restricting, rather than restricting. And the next important thing is we wanted to, the question was, okay, now how, if we are going to allow them to use these, how are we going to assess these? The traditional assessment is not going to suit in this scenario. So we were looking around, and there was one study or one formal piece of work looking at what is a potential assessment scale that can be used when integrating generative AI into teaching and learning. And this is the paper that is talking about this. And they identified we can operate at 5 levels, starting from 1 being no AI and 5 being full AI. But the recommended, or what we went at is level 4. AI for task completion, but with human evaluation. So the idea is we allow the students are allowed to use generative AI in their work, but at different levels, we will collect an evaluation of their work, or they have to reflect on, basically that was the idea, they have to reflect on what they are doing and how they are using these tools. So this is, so we were operating at the level 4. You can use AI for task completion, but it should be followed up with the human evaluation. And then, so next I'm going to talk about, so we did the course delivery, but we changed the assessment criteria, and we did 3 things. We did a formal feedback gathering from the students, and we did an informal qualitative feedback gathering from the student with an in-class discussion, and we also gathered the feedback from the evaluators to gauge the change, whether we have done a change at all. So this to gather proper way to gather feedback from the students, we followed this approach. These 2 papers, one is coming from looking at how generative AI is adapted in psychology education, but the second one is in fact actually looking at, it introduces this framework called Unified Theory of Acceptance and Use of Technology. The original motivation in this paper is very, like, if you want to introduce, if you are we are introducing robots, for example. If you are interacting with a robot, you are introducing robots into the community, in the society. How do we measure their acceptance? So this was applied in that context, but we adapted that into, it was on robotics, relevant to robotics or robots. But now robots are not like tangible, but tangible elements that we used to see. But now it's Gen AI. So we adapted the same thing into something, I would say, intangible, generative AI. What we did there was we identified 5 categories. We identified 5 categories to gauge their feedback on use of Gen AI in their work, as perceived knowledge of AI, attitudes towards AI, the intention to use AI, perceived social norm regarding the AI, and perceived ease of use of AI. So as I told you, this was a 1 year back when the Gen AI was coming into play. And this cohort is they are computer engineering students, so you would assume they are tech-savvy students. And so this was their feedback on the perceived knowledge of AI. Both male and female has a similar rating of more than 3 on their knowledge on AI and machine learning, how much they know about AI and machine learning to start with. And we ask about questions like rate your knowledge on AI and machine learning, and rate your knowledge on AI and machine learning in comparison to other group members of your group. So we can measure how much they know about these concepts. That was the idea. Then we want to measure attitude towards AI. We ask around questions around likability, their perceived safety, and perceived intelligence. So we had structured questions around those. And we also asked questions around intention to use AI, things like, we asked them to rate these statements. I will continue to use AI-based tools. I recommend using AI tools from the beginning of the next project. I intend to become more involved with AI and AI-based applications, etc. And we also asked about their perceived social norm, because it's a question like, majority in my social circle encourages me to use AI-based tools. They are in a university setup. Just to remind you, perceived ease of use of AI, I find it very easy to get the AI-based tools to do what I want it to do, to relate to how easy they find to use these tools. Again, to repeat, so this is aligning with that previous study that I told you about, where they looked into the acceptance of robots in the society. So it's been adapted. These were adapted, and the study they have done in the psychology education. And wrapping up, with this cohort, we received positive responses for all the categories across what we gauged, and but with an exception for the question, how do you feel your emotion when using AI-based tools, giving a rather lower rating for that question. Both male and female demonstrated similar levels of perceived knowledge on AI, because there's an interest to know. Naturally, we are interested to know whether there would be a difference between the pre-knowledge on these. But in this, we see they demonstrate similar level of perceived knowledge on AI. And under attitude towards AI, a highest average rating was given for the pleasant experience in using AI-based tools, perceived intelligence being the next. And the most importantly, I wanted to highlight, now the course has been completed, and there were 22 groups, 22 projects being conducted, and out of them, 10 out of these 22 have manuscripts in the process of publication. So they have either a manuscript draft, or manuscript in review, or manuscript published from their final year undergraduate research. So I think it's demonstrate the success of the course, and as their as the evaluation panel, the educators, that's great to see. This outcome is great to see. In addition to that, we also had a discussion with the students and qualitatively gathered their feedback on how do they utilize this time they save through using these Gen AI tools. And so they have claimed things like, I can now spend more time on my research, and they have mentioned that there's a lot of them have used these, especially in their literature review step for summarization, etc. And the evaluators' feedback was both positive and negative. Some has said it's great to see the outcomes and how the students have improved. Some has said the evaluation, it's good, but we have to be more cautious. There was a feedback like that. So the picture here is actually a group of students doing one of their presentations, and they are using generative AI in their presentation. As you can see, it's Gen AI based pictures they are using. And if you remove the circles that I have put there, you would have seen that they are all smiling and happy when they're doing this presentation as well. So they and right. So in concluding remarks, so the motto of the University of Peradeniya, it goes as Sarvasavalokanam Sastram. It means, it's a Sanskrit term, it means knowledge is the eye on to all. So we hope, I think we hope and we want to use these advancements including in different technologies, including generative AI, so that the knowledge can be reached to many people as much as possible. Let's hope that we'll be able to do that with these technological environments, and we'll do our best as educators. With that, I wind up my talk. Thank you for listening.
Okay, thanks, Damayanti. Just here. Thank you very much for that wonderful talk and eye-opening one as well. Any questions or comments from the audience to Dr. Damayanti? Okay, right. Okay, we can discuss those things later. So next on, let's move on to the. Let's move on to the keynote speech. It's from Professor Susumu Date, who's a professor of D3 Center of Osaka University. Saying a little bit about Professor Date, he's received his Bachelor's of Engineering, ME, and PhD degree from Osaka University in 97, 2000, and 22 respectively. He was an assistant professor of the Graduate School of Information Science and Technology of Osaka University from 2002 to 2005. He worked as a visiting scholar with the University of California, San Diego in 2005, and from 2005 to 2008, he worked as a specially appointed associate professor on the internationalization of education with the Graduate School of Information Science and Technology, Osaka University. From 2008 to 2023, he was an associate professor with the Cyber Media Center, Osaka University, and since 2023, he had worked as a professor with Cyber Media Center, and since October 2024, he has been a full professor of the DC Center, D3 Center of Osaka University. His research field is computer science. His current research interests include cloud, cluster, and grid, high-performance computing, and their applications. So it gave me a great pleasure in inviting Professor Susumu Date to deliver his keynote on infrastructural challenges towards the convergence of HPC and AI, a case at Osaka University.
Hi. Thanks so much for a nice introduction. I'm very pleased to be here, and I'm happy to introduce our research, our supercomputing center's activity here. Okay, so let me start my presentation. So, actually, I'm now working for the D3 Center. And D3 Center is a new name of Cyber Media Center. So all the organization name was Cyber Media Center. So recently just changed. So, and now I have been working for the administration and management of supercomputing system at Osaka University since 2013. So today I'd like to introduce or briefly overview the activities around the supercomputing systems for the convergence of AI and HPC. Okay, so let me start with the introduction of the University of Osaka. So the Osaka University. So the Osaka University is a national university located in Osaka, Japan, the west part of Japan. And if you are interested, you can go to the Kyoto. Maybe after that, you can drop visit the, Osaka. From Kyoto to Osaka, just 1 hour train. So you can come. And Osaka University is okay. So now under the motto "Live locally, grow locally," Osaka, our university grapples with the challenges of education and research. The organization of our university is structured to cover a wide range of scientific area and education. As this slide shows, our university has 11 schools with 10 corresponding graduate schools, 6 research institutions, and so on. The number of the faculty and staff is 6,516, and the number of students are approximately 23,000, around 23,000. Our D3 Center functions as a national joint research facilities and is expected to support ICT in our campus. So national joint use facility means that our facility, so I mean the supercomputing system, can be used by the Japanese researchers, not limited to our university. So basically, so D3 Center, this is so our computing center is a supercomputing center at our university, and our computing center has a responsibility of providing a powerful, high-performance computing environment for university researchers across Japan as a national joint facility. So, so let me introduce the what kind of systems we have now. This is actually already retired, but first this supercomputer was the first petaflops machine in our computing center. The name of the supercomputing name is Octopus. Octopus is short for Osaka University Cyber Media Center, so all the organization name, and Cyber Media Center over petascale universal supercomputer. This supercomputer was operated from 2017 to the 2024, and so in March of 2024, this machine was retired, and now we are working for the installation of the next Octopus machine. And so around this, so for this supercomputing system was a hybrid supercomputer system. It was composed of Intel Skylake processor and night landing many core processor and NVIDIA P100 GPU, and also large memory machine. The peak performance was 1.46 petaflops. The system was introduced to accommodate the cultivate the new computing demands and needs from basically focusing on AI. And this supercomputer system is being operated currently, and the name is SQUID. So, and the SQUID is short for the supercomputer for quest to solve interdisciplinary data science. And the peak performance of the system is 16.591 petaflops. It is a supercomputing system composed of 3 different heterogeneous architectures. So CPU, GPU, and vectors. You can see the right side of the slide. And for CPU, so we are now providing the Intel Ice Lake-based compute node. And for GPU, so NVIDIA A100 is provided. And for the vector computing node, so we have adopted the vector processors from NEC, Japanese company. Vector processor is good at good for the computer simulations like the weather forecast and fluid dynamics simulation things. And for these 3 different types of computer nodes are interconnected on the NVIDIA InfiniBand HDR 200 gigabps network. And currently, the utilization of this supercomputer system is almost 19% to 100. So now many students and researchers in Japan are using this supercomputer system. Nowadays, especially the people are focusing on the AI, so that's why now GPU nodes utilization is increasing higher and higher. And this supercomputer system also can be used by not only Japanese researchers but also non-Japanese researchers through the framework of JHPCN. JHPCN is a Joint Usage Research Center for Interdisciplinary Large-Scale Information Infrastructure. So in Japan, there are several supercomputing centers in university, and we are working together for promotion and activation of HPC and AI researches using supercomputer system. Anyway, so this framework is basically for the Japanese researcher, but nowadays, so we have a research type named International Joint Research Project. If we can combine the international collaboration team, so you can propose the use of supercomputer system to this supercomputer system in Japan. This is a kind of advertisement. Okay, and so also we have different types of supercomputer system named MDX2 right now. So this is the OpenStack-based cloud infrastructure. So MDX2 system is composed of 60 compute nodes right now, and each node has 2 Intel Sapphire Rapid CPUs, and each CPU has 56 cores running on 2.0 gigahertz frequency. Each compute node has 512 gigabyte memory. These compute nodes are connected on 200 gigabit Ethernet. For the underlying storage, so DDN exascale, so I mean the parallel file system was adopted. And now again, so we have been working for the now we are working for the expansion of this system, and very soon the new NVIDIA GPU has been added to this machine. Okay, and so this is the new machine from the April 2025. Now we are working very hard for the installation of these NVIDIA machines. So we are now setting up the NVIDIA H200 GPU nodes. So the number of the GPU is 28. So actually, this number is very small, but next year we will expand this GPU node again. So maybe I think the number of the GPU number is become double. And so now we are so this machine is so now okay. So in Japan now, there is a movement for deploying developing and deploying the cloud infrastructure for AI research promotion. That is named MDX. And for the purpose, so now east side of Japan, so University of Tokyo has a cloud infrastructure system already. And now west part of Japan, so I mean in Osaka, so our university, now working for the kind of replacement of the MDX1 system located in Tokyo. And also the now, so that's why now we are increasing the CPU and GPU for the AI research in Japan. So anyway, so and this is a spec of the H200, and so maybe you may not interested, so it's okay. So anyway, so H200 is a very new GPU and very expensive, you know, and the GPU node in MDX2 system has a 4 NVIDIA H200. So the now user can use this GPU for AI research or HPC. So this is the introduction of the computing infrastructure which our compute center has. Okay, so from now, so I'd like to explain. So the one of the challenge that we are facing. Okay, so this is actually my goal. So I'd like to establish this type of the infrastructure. So so you know that now, of course, so as this working group shows point out, so now HPC and AI is converging. And actually, our computing center is providing computational resources for basically HPC user, but nowadays, so AI user come to use HPC resources, especially GPU. And actually, so now we are again. So this is our envisioned cyber infrastructure, and the convergence of HPC and AI. And also, we have to think about the IoT also. So now people are now working, people are getting the data from the IoT devices through the internet. So, and some people many people want to analyze such data using HPC and AI. So idea behind this infrastructure is basically the supercomputing system to supercomputing infrastructure. For realizing this idea, so data aggregation is the first priority. So before procurement of Squid system, so our supercomputer computing system around 2015, I talked to AI researchers. Then one of the researchers told me that AI people want to have HPC resources on data, while HPC people look at only compute infrastructure. So I decided to introduce the data aggregation infrastructure named Onion in the center for promotion of AI research in addition to HPC resource. As this slide shows, in promotion in our data aggregation infrastructure, so data generated on campus should be directly aggregated to Onion, so from left top side to the center storage. And otherwise, user cannot analyze or perform the data analysis and computer simulation. So of course, after aggregating the data to that storage, so researcher want to analyze, and after that, so people also want to preserve the data in an open science manner. So that is my very brief view. So question and infrastructure challenges. So of course there are many infrastructure challenges for convergence of HPC and AI. But now my first priority is the data aggregation infrastructure. So again, so AI people want to set up the computer resources on top of the data. So that's why our computer center needs a data infrastructure, so data aggregation infrastructure. So that's why my first priority for the infrastructure challenge is the creation of data aggregation infrastructure, manage enormous scientific data. And of course, nowadays, preservation or research reproducibility is very important issue in the world. So anyway, we have to think about how to manage data for open science era. And also many data sources are there. So in the campuses, there are many scientific devices, such as the telescope and microscope and medical devices. And also now many researchers are setting up the IoT devices on the internet, and such data are generated data every day, and they are requesting the computer resources for the HPC and AI use. So that's why the connection to data sources to data aggregation is very important. Yes, so these are actually infrastructure challenges. So today I'd like to go into the more detail about the data aggregation infrastructure part. Okay, so our data infrastructure is basically named Onion. So let me briefly an overview of the background of the Onion and structure and technical the issues. And from now on. So background of Onion. Okay, so in my observation, even in my observation, the globalization in academic research has been advancing. In fact, researchers are working together for solving a common problem, common scientific problem. The advancement of networking and communication technology accelerate this trend. As a result, research and development where computing resources and data resources must be fully utilized. Okay, but for basically the data resources and in most cases, computational resources and data resources are geographically distributed. So that's why such data have to be combined and integrated. And the left figure shows an example of the international collaboration happening in Osaka University. And one of the research group has been closely collaborating with the University of Kentucky in the area of theoretical astrophysics. In the project, researchers in China, the USA, and Germany are also involved. Someday, so Dr. Kentaro Nagamine, this is one of the leaders, told me, why the supercomputing system in our computing center is not seamlessly connected to the cloud. Actually, this word is one of the shock and one of the motivation for the Onion infrastructure. Another motivation is the left side in the right side in the slide, and Osaka around the 2021, the president of Osaka University showed a vision named OU Vision. And in the vision, the creation of new intellectual value from super big data and the industry university co-creation is is very important. That is one of the motivation. And also, and of course, everybody in this room knows this aspect. So the rapid increase of demand onto high-performance data analysis, including AI, is the background. Researchers are now enthusiastic about applying AI, characterized by deep learning, machine learning, and LLM, to their own problems. Some researchers explore data assimilation technique for raising the accuracy of simulation. Some researchers try to use AI for reducing the computation time of simulation. And some researchers attempt to use AI for judging whether to stop computation or not, or continue or not. So anyway, so for the reason, so data infrastructure that enables the aggregation of diversity data to supercomputing environment is considered essential for the advancement of today and future academic research. And also the active activity towards the research data prevention and reproducibility of research is a strong motivation towards our data aggregation infrastructure. Today, there are many universities, at least in Japan, have formulated the standards and guidelines pertaining to the prevention and management of the research data for promotion of the fair research. On the other hand, a variety of academic measurement data, a variety of scientific measurement data exists, and thus the data management and transfer become the serious issue. So, in fact, in our university, in fact, in our university, some research group which treat large amount of scientific data, send data using the hard disk or USB memory. So I believe so. Taking this reality into consideration, so I believe we have to take a role and the responsibility of data management as a supercomputing center that treats large amount of and large-scale data. In other words, so we must provide data infrastructure that facilitates the proper management of digital research assets. This is the background. And so very old time, so our computing center just provides a very simple interface for data transfer, for data and data sharing. So now, so in the era of the HPC and AI era, so AI researchers always complain the easy data sharing and the easy data management is important. So that's why we decided to set up the, we decided to establish the data aggregation infrastructure through the procurement of this supercomputer system. So this is the slide shows this slide shows the onion concept in the procurement of the squid. So actually for squid system we have built into the 5 challenges. One of the challenges was the data aggregation infrastructure. So we needed the data we needed to have the functionality of getting the data from the cloud to our storage, and also we have to get the data from the scientific devices on campus and IoT devices on campus to our storage system, so that the researchers can immediately perform or utilize the data. And also after computing, so after computation, so researchers want to share the data with a researcher outside of Japan, even if they don't have supercomputer systems account. And so this is a very basic view of our data aggregation infrastructure. So, okay, so now, so in the center part, so is the onion, and so now, so before, and so anyway, okay, so in our university, so many other research centers and graduate school and department, and many people are now setting up that IoT devices, and also they have their own storage system, and also some users are using cloud system. So that's why we needed the functionality of automatic aggregation of data from scientific instrumentation devices, and also the IoT devices, and also the data sharing with the overseas research institution is necessary for the HPC and AI research purpose. And also of course, not all users of supercomputer system expert. So that's why we need to provide the very simple portal or the interface for the users. And the user, yes. And also the user sometimes have their own storage system in their lab. So in the case, so the user want to connect the such storage to our infrastructure. And so basically, from this requirement, so we have designed and implemented already the data aggregation infrastructure named Onion. This slide shows the internal structure of Onion. So as shown in the previous slide, so now we have combined, okay, so 3 different storage solutions. So one is the Nextcloud, and one is the exascaler as parallel file system, and other one is the hyperscaler as object storage. And so for the seamless integration, so we have adopted AWS S3 protocols, and as a result, so we can solve every requirement shown in the previous slide. And this is one of the benefit of the brought by the Onion. And when the user submits a job, that user can configure the schedule system of the HPC system, so that the user can receive email when the job is completed. Thanks to Onion, now user can share the data with the collaborating. The user can share the data with collaborators using smartphone, even while he goes out for shopping in the outlet mall. And the Onion web interface allows user to choose the file of interest and configure it as a shareable. This is possible. And this is a view of from the user perspective. So now user can access the data on our parallel file system for the supercomputing systems, and also the user can access the data on the object storage for preservation purpose, and also the user can connect their own research laboratory data to the our Onion infrastructure. So user can get the single disk image of these. And now, as a result of the so far, as a result of the Onion provision, so now many people are using our data aggregation infrastructure, and this is one of the typical example. So now in our university, there is a center named a core facility. So core facility is in charge of the managing and operating the scientific measurement devices on campus. Basically, these devices are provided not only Osaka University, but also researchers in Japan. And so so now right side of this slide shows system infrastructure. So now, okay, so okay, so okay, so center side, so you can see the Onion. So bottom, so you can see the management, data aggregation and delivery system. The system is developed by our user, and our user now trying to connect the the scientific data to Onion and through the S3 protocol. And now they are aggregating the data in the center from the scientific devices. And some of the data are automatically synced to the Onion data infrastructure. Right after the synchronization and transfer of the data, so the user can immediately perform AI and simulation things. And after that, so now such data can be, such result of the computation and AI can be shared with the Onion infrastructure or properly managed by the NII Gakunin RDM. So in Japan, so there is a research data management infrastructure operated by Japanese research institutions, NII. And now our Onion system is connected to Gakunin and RDM infrastructure. Okay, so I have to wrap up. So this is another try. So now, as shown in the previous slide, so now many people are using the Onion infrastructure, but our Onion system is relying on the campus network, so which, on which the many lecturers and scientists using commonly. But so that's why performance is issue. So now we are trying to connect the dedicated network to the several departments on campus, so that they can directly and efficiently transfer data from scientific devices to our Onion infrastructure. And now we are working for that. And actually, this talk, actually, I will talk more about Red Onion project in the APRG working group on the 2 days later in the morning. So if you are interested, please come. Okay, summary. Okay, so my concern and the infrastructure challenge. So basically, so data aggregation infrastructure is very important for the convergence of HPC and AI. So this is my view. And now we are, so from such view, so now our computing center working on the creation of data aggregation infrastructure to HPC resources, so named Onion. So now, performance is also an issue for data transfer. So that's why we have working for the research enhanced, so Red Onion project. If you are interested, please come to the APRG working group. And also the many things are requested from the AI researchers. So now, still, actually, I know that the data aggregation infrastructure is not only the infrastructure challenge, but I know there are many infrastructure challenges. Yeah. So software stack of the HPC and AI is very complicated for a supercomputer system. But anyway, so I hope this talk can even give a bit useful information. Thanks so much.
Okay, thank you very much, Professor Date. That was very inspiring and all that. So, any questions from the audience?
Thank you for that presentation and all the details, very nicely laid out. The question is on infrastructure. Mm-hmm. I hear from other data centers about energy issues and challenges. Mm-hmm. Are you facing similar challenges or are you okay?
Yeah, of course, the power is very important. So now, okay, so NVIDIA, NVIDIA 8200 is actually from the catalog, so consume the 700 watt. Yeah, and so now we have it for so even one computer node. So 2.8 kilowatt only for GPU, and also now CPU is consuming the power of 500 watts. So that's why we are using the liquid cooled. So our computing center's resources everything directly liquid cooled, and we are trying to reduce the computer energy also. Yeah, that is very big issue. So nowadays, so the data space was actually problem, but nowadays, so semiconductor is very intensive, and so heat is a problem, and so now processing devices consumes a lot of the energy, and also the cooling is also the consuming the power. So of course, there's a problem.
On the same line, are you seeing them as limitations for future expansion, or you don't?
Yeah. So so in our university case, the problem is the contract of Osaka University with the power electricity. So anyway, we have to and we have to anyway expand. Yeah, that is a very big issue.
Thank you. Thank you.
Thank you for your nice talk. I have one question regarding building this kind of platform, especially for researcher and education. So I guess that data privacy is a great issue because who owns the copyright of this data, and there are a lot of privacy issue also there. How you actually overcoming that kind of challenge?
Yeah. So this is a very good question. A question comment. So yes. Okay. So far, so this is especially in true in Osaka University. So now, so far, president of Osaka University. Now, president of Osaka University is from the computer science. But very soon, the president will change to the medical people. Okay, so that's why, and also medical people are very seriously think about the importance of AI, and data privacy issue is very important. So that's why now I'm planning. So I'm planning to I'm planning to okay. So our Onion infrastructure is for the Onion infrastructure basically is a storage system shareable by many people, but actually we cannot satisfy the data privacy or data security issues from the medical people. So that's why now we are trying to connect the storage onto the storage on the medical school or medical hospital to the Onion, but actually we can this is a dedicated line. So so you can see the switch switch in the CMC's area. So I'm thinking about the setting up the one more dedicated network to the different building. Yeah, and we are now trying to set up the new data center in new data center room for secure data, and maybe we are now trying to separate the data anyway to the different area, and now maybe very soon we are, and also now I'm working on the disaggregation computing environment. So now GPU can be the disconnected from the CPU node, and maybe we can connect or disconnect. We can control maybe. So for the future, so now I'm thinking about set up the GPU on top of the privacy data, and if data medical people want to use the data, compute analysis data on the GPU, so maybe we can connect or disconnect. So maybe we are, this is a challenge. So anyway, so now I'm testing just the research level, but data security and privacy issue is very important, so very difficult. So we have to separate that compute resources and network resources and storage resources temporarily and space basis. So.
Okay, thank you so much.
No, I not solved yet.
No, I understand that it's a big challenge, but thank you so much for your answer.
So actually I have been working on with the medical hospital people and dental hospital people, they are requesting a lot, but difficult to solve. Yeah.
Thank you.
Okay, yeah, we can take one last question.
Hello. Thank you for that interesting presentation. I have two questions. The first one is, you mentioned that the utilization of your compute resources is around 90 to 100%. I wonder what is the utilization for your storage resources?
Storage is actually actually a lot, but we are now set the quota for the storage system. So that's why now we are refraining the usage of the storage. We release the storage. I think the 1 week everybody use. So so now actually in our case our computing center charges less than $20 for every 5 terabyte. Yeah, but user want to use money for computer resources. So, but anyway, now we are. But some of the users are requesting more than 500 tera or yeah. So in the case, especially sometimes our center especially permits the use of the data.
I see. My second question is, it's related to the one you mentioned. What are your storage policy when it comes, let's say a researcher or a student requested a storage space, how much will you give, or what is the deletion time or the amount of time they can use that storage before it gets deleted? Sort of like.
So you mean say again, please?
The storage policy.
Storage policy, yeah. Storage.
Yes, yes.
Yeah.
The retention time of the data on the storage. Do you have that kind of policy in place?
Actually, so actually our supercomputing system is basically the 1 year contract.
Oh, I see.
Okay, I see. And if you contract with us, so we give the 5 terabyte. Okay, from the 800 US dollar. Okay, so if you pay 800 US dollar, I think you can dedicatedly use the A100 GPU node. I think for 3 months.
Oh, okay.
Yeah, we just charge the electricity consumed by the computation.
Okay,
And and for that data, so basic default, so you can get 5 terabyte. So if you want to add, so you need to pay the less than 200, less than 20 US dollar for. Yeah, so some 5 tera, one, yeah, something like that.
That's
yeah, not so expensive.
Okay, thank you.
Thanks so much.
Okay, thank you very much. I think we have to move on. So thank you so much, Professor Date. That was very inspiring, and once again, it's a brilliant speech. So thank you very much once again for.
Thanks so much.
Okay, once again, so this as a very brand new working group. So I invite you to actually join the mailing list. So we have a lot of things planned for the future going forward. So if you have not joined the mailing list of the working group, please join, and you can share this with your colleagues who would like to be part of this. We want participation of actually a large community, so that we can decide on. There are many things that are coming up. So a couple of things, a very quick introduction to a couple of things that are coming up before we wrap up the meeting today. So the important thing next is the third International Conference on HPC and AI. As I mentioned, we started this conference back in 2023, August, in APAN 56 in Colombo. and we had the next iteration at APAN58 in Islamabad. So basically, this is conducted or actually initiated by the working group of HPC AI, but it's organized by the University of Peradeniya in collaboration with the local organizing chair of each APAN meeting. And we are having it once a year on even-numbered APAN meetings. So the next one is going to be at APAN 60. As I mentioned, so even though we initiate it through the working group of HPC AI, the main task of organizing and handling has been done by Dr. Damayanti Herat over the years as a main organizing chair. And actually, one of the things I missed to mention was Professor Date was actually in the original or the first organizing committee of the APAN conference. So sorry for missing that out previously. So thank you very much for actually helping us launch APAN conference at APAN 56. But to officially launch the APAN conference for 2025, let me once again welcome Dr. Damayanti Herat.
I'm excited. So everyone, hi again. I'm excited to announce the happening of APAN conference, APAN third conference 2025. It will happen on 31st of August 2025 in parallel with the APAN meeting of APAN 60. And the theme of the conference goes as AI and HPC, powering the next frontier. And we have now opened up the call for papers. The paper submission will be open till 1st of April 2025. As it was said, we had the inaugural conference in 2023, APAN 56, and the next one in 2024, APAN 58. The theme was AI and HPC, better together. And this year, we are changing it to AI and HPC, powering the next frontier, to appreciate the role of AI and HPC, its essential role in driving different disciplines, driving innovations across disciplines. And the proceedings of the conference are planned to be published in Communications in Computer and Information Sciences, CCIS, published by the Springer. In 2024, we had 56 manuscripts submitted to the conference, and we accepted 15 of that work. In 2025, we had 37 manuscripts submitted to the conference, and we had 11 of that accepted. In 2025, we are looking forward to getting as many work as many possible submitted for the conference and presented. So we look forward to, we invite you all to spread the word, and we look forward to receiving impactful research around AI and HPC being submitted to APAN Conf 2025 and make a platform at the APAN 60 meeting, make a platform to take them to the world. So I invite you all and expect your contribution in terms of spreading the word, as well as your contribution in reviewing this work as well. Thank you for this opportunity.
Okay, thanks, Damayanti. And actually, there are some flyers over here. If you want to know about the information, there are some flyers about the conference over here, which you can get. Right, so you have 5 minutes left. Okay, so the next important thing is actually a white paper. So we actually presented this in APAN 58 as well, but since we had a very limited crowd, we didn't move ahead with that. So we have, as I said, we are looking at different aspects of it. I'll just give you a glimpse of the white paper because we don't have time to go through and discuss the white paper here at the meeting. That's why I said, so once again I invite you to join the mailing list. So because will be sharing this through the mailing list where we can have a discussion. So just to so we are looking at different aspects in this one. This is quite long, actually. So we are looking at basically the executive summary. If you look at, we're looking at the synergy for innovation, regional collaborations, capacity building, infrastructure and data sharing, and policy and ethics. And the call for action. So what we're going to plan to do. So this is basically where this entire white paper is focusing on. It's a bit long one. So just for the sharing and easy reference, we have made a concise version as well with some bullet points and all that. So we'll be sharing this both versions with you, where you can give your input and we can adapt this formally. We're going to discuss this at the REN Leaders Forum. We have this REN Leaders Forum, which is happening. It's a clones event open for the REN leaders. But to look at how the research and education networks across Asia Pacific can come together and form an alliance as to how to go moving forward with HPC and AI in the current age, where this has become the hottest topic, and also have the possibility to either elevate everybody or make the digital divide even further. So there's not much time left for us to just keep talking about it. It's time to take action. So we are looking at how that can be done. So I invite once again to join the mailing list and give your input as well for this white paper and how we should move forward, so that we can incorporate your ideas into the white paper and call to action going forward. Please invite your colleagues, your friends, and others who would like to join and participate in this working group to join as well, so that we can take everybody's views and hear from all regions, all corners of the region, because we understand even at the moment, I mean, looking at what Professor Date presented, what is done in Osaka and Japan, and in you say we can say Singapore Supercomputing Center, Thai Supercomputing Center, and so on, and also towards the least developed countries and the middle income countries. So there's a vast difference that has been generated and moving forward. So we need to look at how we can bridge this divide in the region, and what are the things that we can do from both sides, from infrastructure, operations, innovations, to the policy and so on. So please join hands with us and give your input, so that we can form a considerable alliance moving forward in HPC and AI in the region. So with that, I'll bring the session on the working group on HPC AI to a conclusion. And also, just before finishing off, we are also conducting a workshop on generative AI called AP GAINT, Asia Pacific Generative AI for NREN Empowerment and Development, on Wednesday and Thursday. The registration for that workshop is already closed. Those who are registered and complete the course will get a certificate, but everybody else is also invited. If you are interested, you can participate in the workshop, because once again, we are trying to see how generative AI can be used to strengthen the NRENs across the region, and in turn, how it can support education and research in the region as well. With that, I bring today's sessions on the working group on HPC to a conclusion. Thank you so much for attending, and have a pleasant day.